Okay, so finally we will talk about trigonometric. These are the graphs for the real part, imaginary part, and modules. So we'll come back to this. Definition of complex sine and cosine. So recall, by Euler's formula, we have cosine of theta is e to the I theta plus e to the I minus theta. And sine theta, you put a minus. You put a minus and you divide by I. So it turns out that it works the same if we extend by z. For z complex, we define cosine of z. So define. Here we're defining. That was an implication. Here we are defining. So e to the I z and e to the minus I z. And sine z is defined as e to the I z minus e to the minus I z 2I. Okay? So this is our definition of complex cosine and complex sine. And from here you can even define tan if you like. So tan of z is the ratio. And so on. So as soon as you have cosine and sine, you can build the rest. All right. So let's do some examples to get an intuition. Okay. Let's start with this guy. So find the real and imaginary part of sine of minus 4i. Okay. Right. So we use our definition. This is e to the I minus 4i, and then minus I minus 4i. Right? So this is our z. Z. Okay? Now let's try to simplify this. Right. So the I cancel out. So you get 4 because I squared is minus 1. And here again, you get a minus, but you have another minus. So you get minus 4. And right, so you divide by 2i. Okay, good. All right. But yeah, you can bring in. So yeah, use that 1 over I is minus I. So we have minus I, and then e to the 4 to the minus 4, 2. So this is it. Sinus of minus 4i is just this guy here. with a zero real part. Okay, so that's the answer. But here's something interesting here. If you compute the modulus of sine of minus 4i, it's just this. So e to the 4 to the minus 4 over 2. And I did the computation, and this is about 55. So why is that important? Because you see, recall that for x in minus infinity, infinity, so real x, sine of x is between 1 and minus 1. But this is no longer true for complex. So please be careful for sine z. And I picked this example specifically to give you this. So you can see that sine of minus 4i is about 55, which is much bigger than 1. So it breaks, it doesn't satisfy the inequality. Okay? So I hope that point went across. All right. So let me do one more example. And if you want more, just tell me. Okay. So this is a common question. It says solve the equation cosine of z equal to minus 3i. Okay. So, right. So let's use the definition. This guy was defined as e to the iz plus e to the minus iz over 2. So we want to find z. So how do we do this? First, we need to get you will get a quadratic equation. So what do I mean by that? Set w equal to e to the iz and c equal to whatever the right-hand side is. Okay, so do that first. You get w plus 1 over w equal to divided by 2 is equal to c. Now simplify the expression and you will get w squared minus 2cw plus 1 equal to 0. All right. Okay, so again, we set this to make calculations easier. We do this shorthand notation. You don't have to do it, of course. You can just, but it makes it easier. And now solve the quadratic. The hope is that by finding w, we can then find z, right? So again, by saying solve the equation, we mean find z. Such that it satisfies that equation. Okay, so we solve the quadratic. What was it? We get w equal to c plus minus c squared minus 1. Okay. Now use that c is minus 3i. And you get I minus 3 plus minus square root 10. Okay, so that's W. But what was W? W was e to the I z. Okay. So now we have to solve this. I should let me write it here. So we have to solve this guy for z. Now that takes us back to solving equations for log. So again, use the formula for log. That we proved. So we have log of I minus 3 plus minus square root 10. Is defined as follows. So first we have ln of the modulus. And plus I argument of this guy. So argument of I minus 3 plus minus square root 10. And then plus 2 pi n as usual, where n is an integer. So so what remains here is to find this argument. So find argument. For simplicity, let me call this constant a. Now recall that I is equal to e to the I pi over 2 by Euler's formula, and a is a real number, so we get that the argument is just pi over 2. Okay, so let's finish this. So 5, taking, let me call this equation. So taking log of that star equation, of both sides of star, gives the following. Gives log of AIZ is equal to log of I minus 3 plus square root 10. And we found this above. So that was ln of minus 3 plus square root 10 plus I of pi over 2 and 2 pi n. Okay, so we're almost there. So then z, Iz is equal to the same number. Let me not rewrite it. And then divide by I to get you know, 1 over I ln of minus 3 plus square root 10 plus the real part, pi over 2, 2 pi n, ending z. All right, so these are all the solutions to cosine of z equal to what was it? Minus 3i. Okay, so we run out of time. If you want me to do more examples for trigonometric, just tell me.